Hi, everybody. Welcome back. Week 5. We're getting close to the end of the year. Seniors, if you're watching this, make sure you go back and look at the senior bio portion first before you start into this. So you can enjoy your last week as a bulldog. You'll always be one, but like an official bulldog, right? So for everybody else, let's get rolling. We're going to talk about solving exponential equations this week, right? And basically, we're going to look back at what we've done with our logs and our exponents and use those to help us solve for x or some variable. Okay, so first we're going to solve the following exponential equation. And we want to think about how you know when an equation is exponential, right? So when can you use these skills versus all the solving skills you've had in the past, right? So we want to make sure we recognize that 3x equals 9, right? That these two things are different, right? This is 3 to the x, some power. This is 3 times x, some number, right? So if we were to solve for this, you just divide and go through and you'd get x equals 3. But let's look at what we would get if we solve our exponential equation. Since our x is in the exponent, that's why we consider it an exponential. So if you're just kind of thinking of this, right, we want to, some of them will be easy like this, where you kind of just think through, and then we'll talk about some more skills to solve them as we go on. So we want 3 to some exponent is going to get us 9, right? And so we're solving for this exponent, and you should say, all right, 3 to what power gets me 9? And hopefully you can think through and say, all right, x has to equal 2, because 3 squared equals 9. Right, and so these are really nice ones when they work out easy and they're like an actual whole number power, where you get x equals 2. Okay, so sometimes they're nice and easy like that. This next one is also pretty nice and easy. So notice we have our exponential equation, and both things have the same base, right? Both sides have the same base. And so that tells us, when both sides have the same base, that we need these exponents to be equal, because there's no way you can say 10 to the third is going to equal 10 to the fifth or eighth. That looks more like an eighth, right? So 10 to the third is definitely not going to equal 10 to the eighth. And so we have to get to a point where our exponents are the same, or they're equal. And so if you have the bases are the same, all you got to do is say, okay, my bases are the same. Let's get rid of those. And we're just going to look at x plus 4 equals 9. Right? And from there, you should say, wow, I hope he makes the quiz all of these questions, because I can do x plus 4 equals 9, because you should get x equals 5. Right? So that's when we have our same base. We started with our same base here, base of 10, 10, and 10. And so if we have our same base, we know we can set the exponents equally to each other. Okay, so those first two, pretty straightforward. Let's keep going. This next portion is when we're going to have to use our logs, right? So just like when you need to cancel out multiplication, you have to do division, or if you want to cancel out addition, you have to do subtraction when you're solving. That's why we have these nice logs, because when we're given exponentials that don't work out really easily, like the previous two, we want to be able to use our logs to help us solve, right? So that log kind of cancels out our exponent. And the main log property that we want to talk about is when we have log, still can't spell, even sitting at home, log base a b to the c power, right? So this is log base a of some number b to the c power. That lets us bring the c out front, and we get c times log base a of b, right? And this is our very important log property for solving, because it brings this exponent down, right? It gets the exponent out of our exponent, and so then we know how to deal with multiplication. So let's try to look through this one. So initially you look at this and you say, okay, this looks like the first one we did. Should be pretty easy to solve. 2 to the what power gets you 10? Well, good luck finding that on your own, because it's rather difficult. Since it's not a whole number, don't say 5. Please don't say 5, because 2 times 5 gets you 10, not 2 to the 5th. 2 to the 5th gets you 32. Okay, so then let's think about how we can get this x out of our exponent. Well, it's helpful on our calculator, because our calculator can use log base 10, or we have the ln button, which is log base e. right? So you can choose to use either one of these. Sometimes it's easier than others. Okay, so let's say I like to use log base 10, right? Because this ln and e is kind of a little more messy. So we're going to use log base 10, which in your calculator is just log, right? That's what we talked about last week. If you don't see a base, it's always base 10. And so we are going to take this first example. We're going to say, okay, move this down a little bit. We're going to say, okay, let me take the log of both sides. So log of 2x, whatever, when you're solving, whatever you do to one side, you got to do the other, equals log of 10. Okay, so now we've got to this point where we have this property, right? We've got log base 10 of something gets us x. And so that's going to allow us to bring x down. So from here, we can bring x down. X times log of 2 is equal to log of 10. Now we're in a really good place because we have no exponents, and all we got to do is get x by itself. And so in order to cancel out multiplication, x times log of 2, you just got to divide by log of 2. Again, hopefully you recall whatever you do to one side, you have to do the other. So we get x equals log base 10 of 10 divided by log of 2. And when you punch that in your calculator, log of 10 divided by log of 2, you get approximately 3.3. Right, so not too bad. We use this key property we have to help us bring that exponent down. And so that kind of strategy is what we're going to be using for the rest of these, of bringing the exponent down like that. Okay, so same here. We have an exponential, our x in the exponent. We say, okay, let me take the log of both sides. Log 3, 6x equals log of 7, right? All we did was log both sides. Now we've got that 6x we can bring down. 6x log of 3, times, equal to log of 7. Same thing we did over there, divide by our log of 3, divide by log of 3, divide by log of 3. Only thing this time is now we're left with 6x equals that. So let's compute this in our calculator. So log of 7 divided by log of 3 gets us about 1.77. And lastly, right, you're at a point that you should definitely know how to do this next part. Divide by 6 on both sides, and you get x equals approximately 0.29, let's go 5. So right, really close to 0.3. Make sure when you're doing these, if you do round it all like we rounded at this point, it's possible you're not going to get the same answer exactly that's given. And at that point, make sure you go with the closest one. All right, so let's keep rolling. Let's look at this next one. Let's give us a little more space. There we go. All right, so notice we introduced this e. You can use ln since you see an e. You can use log. I would just keep using log because you can always use log. Okay, so again, we have our x in the exponent. So we got to go log e of 3x plus 1. Terrible writing, Matt. Oh, there you go. You just figured out my first name. I haven't thought about myself as Mr. Wisniewski in quite some times, other than sending emails. Is equal to log of 4. Okay, so we did our log thing. Now we can bring out that 3x. So make sure you 3x plus 1 times log e equals log of 4. Got to divide off by our log. Divide by log e. Divide by log e. And we get 3x plus 1 left over, right? This chunk's left over, is equal to, let's plug this part into our calculator so we don't have to rewrite it. So we got log of 4 divided by log E. If you don't know where the E button is, you probably skipped last week's, but it's the division. If you hit second divide, and we get about 1.386. Okay, from there, right, we solve it just like normal. Subtract your 1, then divide by 3. So we get 3x equals 0.386. 0.386 divided by 3 gets us x being approximately, let's put our equal sign though, 0.129. Right, so again, our main thing is that we're getting, first thing we're doing is logging it because our x is in the exponent. Divide off by the log to get this piece by itself. And then from there we are back to our, I don't know, 9th grade solving days, 8th grade solving days. All right, lastly, last one for today's material, we're going to look at what happens when there's something before you log it, right? So all the rest we had to log first, but notice there's like this little piece out here. And an easy way to deal with that is if it's not in the exponent and it's not your base, deal with it first. If we look back over at this one, if we look back over at this one, notice we had nothing else up here, right? Nothing else was up here. We just had the thing to the exponent, and then the other side. We're over here. We have this piece, right? Not in our exponent. So let's get rid of that. Just like normal, getting rid of it, you subtract it off. So let's say, I don't know why they'll even let me change the eraser color. Subtract 2, subtract 2. Okay, that gets us 4 to the x minus 1. 4 to the x minus 1 equals 5. My pen is not cooperating right now. Equals 5. Okay, and now we're at a point where we just were. All we have is the thing to the exponent on the left, so let's log both sides. Log 4x minus 1 is equal to log of 5. And that lets us bring down this x minus 1 times log of 4 equals log of 5. Just like we've done in the previous, divide by our log of 4, divide by our log of 4. That gets us x minus 1, right, because this part got brought down, is equal to, let's compute this part, log of 5 divided by log of 4 gets you about 1.16. And then from there, lastly, hopefully you're like, okay, all I got to do is add 1 to it. So we add 1. Okay, cool. We add 1 to it, and we get x equals 2.16. Right, so make sure you take care of anything that's down here first, right? Whether it's addition, subtraction, multiplication. Then you can log it like the previous ones if there isn't anything else there, right? So notice all the previous ones. All the previous ones just had the one piece. Now this had 2 pieces. So make sure on those first 3 you're doing your log first, and then on the last one you do your log second.